Good morning, everyone. Today I'm going to talk about the long-term tensile stress of GFRP. My name is Wang Dong. Now, I will introduce the content of this presentation. Firstly, I will introduce the overview of the fiber-reinforced polymer. After that, I will do some literature review of what investigated before and the gap of previous studies, followed by the design question of my topic and design method of the question. I will evaluate the advantage of and the limitation of my design method and the result. Also, I give you some conclusion of my presentation. Now, I will give you brief introduction and of the FRP. FRP named fiber reinforced polymer. It is composite mixture made and polymer reinforced by fibers, and contains 4 different types using in the engineering fields, including carbon, glass, basalt, and amide. In the past few decades, FRP gains its popularity because of the advantage comparing with the traditional construction materials, such as the tensile strength, comparative strength, and corrosion resistance. However, it also has some disadvantage, which is fair resistance. Now, I will give you some information about the lecture review. According to Seal in 2016, the GFRP has impacts on the classic modulus of the steel. It can increase the elastic modulus of the GFRP rebars up to 250% than its original properties. Particular GFRP demonstrates a significant improvement of the tensile strength of the concreted and elastic modulus. It usually increases the tensile strength up to 5% than its original. For the environmental effects, according to the in 2018, the effects of the alkaline environment can be ignored for the tensile strength of the GFRP concreted column under the temperature, which is not outstripping the 40-degree. More the tensile strength and bond behavior of GFRP, concreted column can be dramatically increased up to 900 MP. Furthermore, with the increasing performance of the traditional construction, material has been sought for the restore tensile stress after levity fair. According to the Alice in 218, First of all, it remained 83% of the original tensile strength. The tensile strength of GFRP bars remains stable at the temperature of 90 degrees. It has significantly decreased after the temperature reaching the range between 300 to 450 degrees due to the different thickness of the bars. The minimum temperature of 20 degrees to the room temperature has not significantly impact on the tensile behavior of GFRP limits. The gap of previous study does not contain the long-term tensile stress in the different environment conditions and different shape impacts on the GFRP. In order to solve the gap, my design question in the long-term tensile strength of the GFRP using in the building and bridge in different environmental conditions. It is important that the long-term tensile stress can improve usage period of the building and the bridge, decreasing the cost of the repairing period. In my design method, I use the parameter controlling method to design to evaluate the tensile stress of the FRP placed into different environment conditions. Also, the tensile stress test system to test the tensile stress after a period of the supporting beam or slabs in different environmental conditions. This design showed the gap of the impact of environmental conditions of long-term tensile stress of GFRP and different shape effects. However, due to the results from the simulation test, it cannot directly use into the real condition. Also, the period of the test only consider to 90 days. In conclusion, GFRP has its advantage comparing with the traditional construction material in several applications. This design in the presentation shows that the long-term tensile property still better than the stainless steel. Thank you for listening.